So in the next question, describe the locus of center of a wheel of a bicycle which is moving in a straight line along a level road. Now consider a bicycle. So I'll make a rough diagram. So imagine that these are the wheels of the bicycle. The wheels are equal and we have to find the locus of the center of a wheel. So this is the center of a wheel which is moving in a straight line along a level road. So this is a level road and the wheel is moving, let us assume this side, doesn't matter. So I'll focus on one wheel only. Now, if you look at this, if you look closely at the center, see, when the wheel comes here, or it comes here, or it comes here, because it's a level road, the center would remain the same. So these would be the different locations at which the center of the wheel would be there. Now I just delete the wheels. So you'll understand that the point is moving something like this. So this, on this line, the center of the wheel at various time would be there. So this is a straight line. So what is the locus? Locus of the center of a wheel. So it's a straight line. So what will you write in the answer? You will write the locus on the center of a wheel is a straight line, parallel to the road at a height equal to the radius of the wheel. So beautiful answer. So what you will have to, you can also mention is that this is the radius of the wheel. So I hope this is making sense. Let's move to the next question. Okay, next question. Describe the locus of a point which is equidistant from two fixed intersecting lines that form an angle of 60 degree. Again, a beautiful question. Let's try to understand what is happening in this question. Describe the locus of a point which is equidistant from. So, what is the condition on the point? Locus of a point which is equidistant from two fixed intersecting straight lines. So, these are the two intersecting fixed lines that form an angle of 60 degrees. So, they have an angle of 60 degree between them. So, there are two intersecting lines. There are two intersecting lines. The lines are intersecting at 60 degree. The point has to be equidistant from two fixed intersecting lines. Now, see, that is why, I promised you in the beginning that, the more the questions you will do, the more questions you will study, the better you will understand the concept of locus. So, in questions like these, so we need to find the locus of a point which is equidistant from two fixed intersecting lines that form an angle of 60 degree. You need to understand that this point, the perpendicular distance from this and this is say x. Then again I can come to this. The perpendicular distance from this line and this line would be y. Or I'll rather make this diagram here so that you are able to look closely at what I am doing. So imagine a point x here. The distance from this line L1 and the distance from the point L2 should be x. That is constant. So this is my line L1, this is my line L2, and this is the angle 60 degree between them. I hope this is making sense. Always remember that the distance between a point and a straight line is always a 90 degree. This is always the distance. So whenever you see a distance between a point and a straight line, it is always a perpendicular distance. I have denoted it by D here. I have denoted it by X here. Now let's consider another point which satisfies this condition. I can take another point. Let me call this point P. Let me call this point Q. Its perpendicular distance from L1 would be, let us say, y. Its perpendicular distance from this L2 would be, let us say, y. So this is point P, this is point Q. I can take another example. Let me take a point R. Let me extend it. Let me extend it here also. Again, the perpendicular distance from L1 would be, say, Z. Perpendicular distance from this line L2 would be Z. So I can have a series of these points. I'm just considering, this portion. So when I have a series of this point, you'll understand. So this might be the point, this might be a point, this might be a point, this might be a point. So the point is moving. Uh, the point is moving so that it satisfies the condition which is given in the question. And if you are with me, if you have understood the logic, the path of this point would look something like this. Basically, this would be a line bisector of L1 and L2. I hope this is making sense. But then I can have, similar these points here also. Similar points these also. So all these points, so on this line, each of the point will satisfy a condition, that is that it is equidistant from the two intersecting lines which have an angle of 60 degree. And of course, students who are thinking beyond this would also understand that similar kind of points would lie here also, here also, here also, here also. Why? Because the distance, perpendicular distance, would be the same from the two intersecting lines. So we'll have another line which will look something like this, which will have something like this. So these two lines are the paths that the point can follow. The uh, the condition would be satisfied when the point will follow on any of these two lines. So I hope you are getting the drift of what I'm trying to say. So this would be the answer. And in the exam, you can write a answer like this is the answer you can write. The locus of a point equidistant from two intersecting lines forming an angle 60 degree is the pair of angle bisectors of the angles formed by the two lines. That is the two lines that bisect the 60 degree and the supplementary 120 degree angle. So, this is what you can write. And what I have been suggesting is that you can also, draw a diagram. You can write draw a diagram using scale pencil so that the examiner understands that you have understood the question well. So again, an interesting question, and let's move to the next question. Let's move to the next question. So I hope now the locus is making sense. So in the first three questions, I think by the time you will reach the last question, you will understand that how locus operates. So question number 4.